Guys, hello. Good evening to all of you guys. Today we are discussing polynomials in Narayana volume. Who are from Narayana? Please tell in their comments. Please subscribe and like to this video. I'm putting so much effort to make these videos and I improved my quality from worst quality to mid. You rate it in comment section. Today, now we are going to start. Introduction is a real number valued function of f of x is see guys, it's a basic point, like it's a form of polynomial where a is not equals to 0. A is the coefficient of the x. It's the form of a degree of nth term and it's non-negative integer. So you could see here quotients. For examples, you could see there are some polynomials of degree 6, degree 3. It's kind of polynomials. As we go into the depths of the topic, you could see what are polynomials and what exactly are them. Guys are ready to go into the depths of the topic? Please comment in the comment section. Here comes nothing. We are gonna start from remainder theorem. Remainder theorem is the first topic. Now I'm gonna stop the. So this and see guys. Remainder theorem. If f of x is a polynomial and a is any real number, then the remainder when f of x is divided is given by p of a. I'm gonna explain it by writing down in the page. If x minus a is equals to 0 and p of x divided by x minus a you could see here x is equals to a, changing of sides, and is equals to remainder is 0. Remainder is 0 over here, means f of x value is here, so p of a is given. We proved it. Nothing is there in that point. So many people will be confused how it is given by p of a. So guys, it is how it is proved by p of a. I'm gonna remove this. Sorry guys, my handwriting is not that size of good. I'm gonna improve it by the time. Show the proof. Here is the proofs. I told it in a simple way, but you could read some proofs. Minus. See. Let q of x and r of x be quotient and remainder respectively, means q of x is quotient of p of x divided by x minus a and r of x is the remainder of when p of x is divided by x minus a. The division algorithm states that Dividend is equals to quotient into divisor plus remainder, which is nothing but if you 4 is equals to quotient is 2. Yes, it's not 2 into divisor is 2 plus remainder is 0. If we divide 4 is to 2, it is like this. Quotient is 2, divisor is 2 plus remainder is equals to 0. 2 into 2 is 4. 4 plus 0 is 4. So remainder is 0. You could see how it works. And I'm thinking you guys already studied this in the lower classes, so I need not to explain it deeply. That is, P of x is equals to Q of x of x minus a plus R of x. X minus a is our divisor, and Q of x is our quotient. R of x is a remainder according to division theorem, divisor theorem, division theorem, or anything, algorithm or so. Here dividend is P of x over here. Our quotient is Q of x is over here. Divisor is x minus is over here. Remainder is R of x is over here. It is the polynomial if x minus a remainder is equals to 0. It is the polynomial which we are treating with. X is equals to a. I told you right guys, x minus a is equals to 0. If P of x divided like whatever and x is equals to a, then replace the x's with a. P of a is equals to Q of a minus a plus R of a gives rise to R of a only, because a minus a is 0 and R multiplying 0 with anything is equals to 0. R of a remains because we are already adding 0 plus R of a. 0 plus anything is anything only. So R of a is equals to P of a. Polynomial of a is equals to remainder. P of x is equals to x minus a into quotient of x plus polynomial a, because R of a is equals to polynomial a. We could interchange the R of a with the polynomial a. Thus the remainder is P of a. P of a is equals to 0. We say that a is the 0th of the polynomial because the remainder is 0. It's exactly dividing, exactly means taking the number to 0, means it is a factor of P of x. We could tell it as 0th of a polynomial. P of x is a polynomial. A is 0th of P of x. Then P of x is equals to x minus a into Q of x. Quotient into dividend plus remainder. Remainder is 0. So if we take that or not take that, it's the same. So we could not take the remainder if it is 0. Guys, if you take when remainder is any constant, it would go. Your question would go. When it is 0 only, you should not take the remainder. P of x is divided by ax plus b. then the remainder is given to by P of B minus B by A. This is nothing but whatever it may be, x is some technical, x plus e is equals to 0. B this side is equals to ax is equals to minus b. A would go into denominator, so minus b by a. It is what they gave here. This minus, it would go this side to be plus, and it would be plus. So what they gave here. Understood? And now example 1. Find the remainder when the polynomial f of z is equals to z cube minus 3 power z plus 2 is divided by z minus 2. Then z is equals to what? 2. Then p of 2 is equals to z cube, which is 8, minus 3z is 6, which is 6 minus 8 is 2. 2 plus 2 is 4. Understood? P of 2 is 4. And the remainder would be z is equals to 2. So all 8 minus 6 plus 2 is 4. So the remainder is 4. Given that the solution over here, guys, see, just nothing but changing sides, getting the value of the variable and adding it, you could get the remainder. It is called the remainder theorem, and I am gonna give you some time to solve some questions about this. There is no gap, guys, so there is no questions. I am gonna give you in the next video a worksheet. I hope so. There are some more questions. There are a lot of examples, but there here. Let's check in one more book. 1 minute, guys. They gave lot more examples to synthetic division polynomials, but not this remainder theorem. I'm gonna give you question paper tomorrow. Tomorrow I could give you the question paper, and today I hope so I could give you some worksheet today if the time permits. And now I'm gonna tell you about the next topic. It's factor theorem. It is one of a part, we could tell it is the same kind of theorem as the remainder theorem. If p of x is a polynomial of degree n, which is greater than or equals to 1, it is not equals to 0, it's greater than or equals to 1, and a be an real number such that p of a is equals to 0 when x minus a is a factor of P of X. Here they're stating that nothing but the remainder theorem only, guys. When it is exactly divisible of P of X polynomial, when it is a factor of polynomial, when P of A is equals to 0, then X minus A is a factor. They're just telling X minus A, when it divides with P of X, the remainder is 0, then X minus A is a factor. Nothing but the reverse way of remainder theorem. So, remember one theorem, you could get the other one just like that. The same thing repeats again. Division algorithm, you have to get 0, so you could prove that it's a factor. There are some more questions given. There is the proof question example. You could do the example, and I'm gonna tell more of note points are there. There is more topic. This video would be lengthy. It's already 16 minutes into the recording. Guess it's only 3 pages. There are 16 pages in this file which I have taken from. P of minus A is equals to 0 when X plus A is a factor of P of X. When X plus A, not minus, if you take and go plus to another side, it would be minus. So minus A is equals to 0. It is a factor. It's nothing but factor theorem. It is the same things from the remainder theorem. Just factor. There is one more important point over here. Sum of all coefficients of polynomial is 0. Then X is one of its X minus 1 is one of its factor. It could be. It is a factor. It's an important point, and it could be used in lots of questions in 12th and 10th grades. And this book is for 8th graders in Narayana. Guess, if you are a topper, join in Narayana. If you don't know anything, don't join in Narayana. It's the best thing I could suggest you. The sum of all odd and even powers are equal. Sum of questions of all odd and even powers are equal. Then X plus 1 is a factor of polynomial P of X. And guys, I'm gonna give you some time to see and analyze the example number 3 till I prohibit to the next topic. I'm gonna be just in a minute. I'm gonna go for a little break so I could pitch up my voice again.